Hey, all you mathematicians out there, the one and only Mr. G here, coming at you with another lesson, taking a look at those comparison of fractions. We've really come along in this mini unit. Take a look at all of these learning targets that we've been working on. We've had 24ths lessons. Okay. 15 thirds lessons. Editor, I can't see the kids, but I'm starting to feel like they may not completely understand what I'm trying to say with the number of lessons we're on.
I agree, you're doing that thing again. You know, when you don't make much sense. It's really simple, you're just using improper fractions to explain the value or what number lesson we're on. The kids need to have this prior knowledge whether they've been taught it or not. Before it makes sense. They are not teachers or have AI. Mr. G, you make too many assumptions.
Editor, you're starting to sound like my mother.
I am just trying to help. That is what I've been programmed to do. Fractions are difficult to understand. That's why you have programmed me to help you with this unit. Let's just teach the kids. Stop being a grouch. Here, I'll cheer you up. Let them know what their materials they need for today.
Thanks, editor. Today, you'll need a paper and a pencil. All right, editor. So I guess if we want the kids to compare fractions and really have the full understanding of fractions and their value, we should probably look at the other kinds of fractions that actually are as big or greater than a whole, because who knows, they may have learned it before or not. But we need to make sure, especially when other teachers or myself start asking them to start doing things with them, like the operations, adding, subtracting, multiplying, and dividing.
Indeed, let's start there today.
Good idea. In that case, let's take a look at those learning targets. Our first learning target. I understand that improper and mixed fractions have values greater than a whole by comparing and converting. So, taking a look at improper and mixed fractions and understanding that it's greater, alligator, than a whole. And, of course, with this mini unit being about comparison of fractions to help us really get a full understanding of the value of that fraction. Using models and strategies based off of halves and wholes, I can compare proper, improper, and mixed fractions. So we'll be using a lot of those understandings from last lesson, finding 1/2, to help us compare all the kinds of fractions. All right, editor, work your magic.
Proper fractions, a fraction that is less than 1 with the numerator less than the denominator. Improper fractions, a fraction in which the numerator is greater than the denominator, such as 5/4. Mixed fractions or mixed number, a number consisting of an integer and a proper fraction.
Yeah, we're definitely going to have to address this using some models in our IDO, especially using that magnet strip. All right, guys, let's become a little bit more familiar with the definition or meaning of all the types of fractions before we start comparing them to have a full understanding of the value of fractions. Let's start off with the one that we're most familiar with, that we've been working the most with: proper fractions. A proper fraction has a numerator that is less than its denominator, and it's always less than a whole. We've been talking about fractions up to a whole to understand what those numerators and denominators really mean. Let's take a look at a few examples of some basic proper fractions. Starting off with those quarters. We know quarters have 4 parts to make that whole. That is why there is a 4 in the denominator. Okay? So, as we began decomposing these proper fractions, maybe I didn't know that before, is that because they are all less than 1 whole, they are proper fractions. 1/4, 2/4, and 3/4 have a numerator that is less than the denominator and are in fact less than a whole. 1 is less than 4. 2 is less than 4. 3 is less than 4. And as we know, or hopefully have understood by now, is that when we have the number of parts the same as the number of parts to make the whole, that indeed makes a whole, or a whole fraction. Let's take a look at another example. Let's look at eighths, for instance. We know that 8/8 make the whole when we're looking at eighths. 8/8 will make a whole. So, eighths is also an example of a proper fraction because the numerators are less than the denominator and are less than a whole. So, 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, and our whole 8/8. All of our fractions that are proper, that have a numerator less than a denominator, and are less than a whole, such as 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, are all proper fractions. That numerator is less than that denominator, therefore making that fraction less than a whole. I suppose one could argue 8/8 is indeed a different fraction of its own, that it's a whole fraction. But I also could assume that many others could argue that it's a proper fraction. Let's leave that argument up to the math gods. Let's just understand that proper fractions have a numerator that is less than a denominator, and because of that, are less than a whole. understanding improper fractions can be a little bit more challenging. That is likely because of needing to have that understanding that fractions are parts of and parts that make that whole. Really understanding what a numerator and a denominator truly means about the value of a fraction. Let's take a closer look. Here I have an improper fraction. 3 over 2. 3 halves. In my brain, I should already be thinking, that's odd, because I know 2 halves make that whole, 2 over 2. So, an improper fraction, 1 has a numerator that is greater than its denominator. 3 is in our denominator, our numerator. 2 is in our denominator. 3 is greater than 2. 3 is greater than 2. Our numerator is greater than the denominator. Because of that, the value is greater than a whole. Let's take a look. I have halves right here. A half is a proper fraction. Proper fractions make up improper fractions. Let's see how that works. I know I'm working with halves. I have a 2 in my denominator. I know 2 halves make that whole if I'm thinking in wholes, which I need to do when understanding the value of a fraction. But we're representing 3 halves. We're representing 3 parts of 2 that make that whole. 1, 2, 3. 3 halves. 3 halves is 1 half greater than a whole, because we have a numerator that is 1 greater than our denominator. 3 is larger than 2. It has more value. We have more parts than a whole. 3 halves. 1, 2, 3. Let's take a look at it using those numbers and doing some decomposing. As we always start with fractions, we need to think about that whole, or later in this lesson, thinking about halves, is that when our numerator is the same as our denominator, that is our whole. Parts of, parts that are being represented with our value. We know that 1 half plus 1 half will make our whole. One half plus 1 half equals our whole, 2 over 2. But we know that improper fractions are greater than a whole. So if we were to add another half, we know our parts that make the whole always stay the same. That would be 3 halves. A half plus a half plus a half, 3 halves. 3 halves decomposed. Let's take a look at another example. 5 over 3. 5 thirds. Again, so an improper fraction, firstly, has a numerator that is greater than the denominator. 5 is greater than 3. If I had a number line here up to 5, I know 1, 2, 3. 5 is greater than 3. It is 2 greater than 3. Secondly, because our parts of are greater than the parts that make the whole, the value is therefore greater than the whole. So, I have some thirds. We know that 3/3 make a whole when I'm working with thirds. 3 equal parts make the whole when we're looking at 3 in our denominator. But we're not talking about 3/3. We're talking greater than a whole. That's what makes it an improper fraction. We're talking about 5/3. 5 is 2 greater than 3. Here is 4/3. Here is 5/3. Wow, look at that. 5/3 is greater than even my whiteboard. Let's take a look at that example using those numbers and decomposing. We know that we're working with 5/3. 1, 2, 3, 4, 5. First step, as always, when we're working with comparing fractions, you need to think about what that whole is. 3/3 is that whole. We know that 1/3 plus another third plus another third is 3/3. Our denominators always remain the same. They have to have equal parts that make that whole. But we're not talking about 3/3. We added 2 more thirds. We added 2 more parts to make 5. 5 parts of. But yet again, we're working with thirds. 3 parts that make that whole. So, 5/3 has 1/3, 2/3, 3/3, 4/3, 5/3 in it. Start always thinking about what makes that whole. Lastly is a mixed number or a mixed fraction. I think you'll see some similarities. Here I have a mixed fraction, 1 and 1/4. Notice how I said and, as if I was adding a proper fraction to a number. 1 and 1/4. Mixed fractions or mixed numbers. Firstly, need to be greater than a whole. We have our whole, 1, followed by a proper fraction, 1/4. That is also why it is called a mixed number or a mixed fraction. It has an integer, a number, or a whole. We know that integers and numbers are wholes. They are the entire thing. They have a value of 1 or 1 whole or tens, hundreds, okay, when we're talking about place value. So it's called a mixed number or a mixed fraction because it has a number in a fraction or a fraction in a number. It has a number in a proper fraction or a proper fraction and a number. Again, another argument. Is it a mixed number or a mixed fraction? Which came first, the number or the fraction? Let's see it using models. 1 and 1/4. That's like saying we have 1 whole and 1/4. But to fully understand the value of a mixed fraction, it's important to also think about its parts. And I think you'll see something in a second here. I know when I'm working with fourths, and I know I'm working with a whole, which could be partitioned into anything. I could have eighths to make the whole, but for the sake of having this mixed number with a proper fraction of 1/4, let's take a look at it with fourths. We know that 4/4 make a whole when 4 parts make the whole. There it is, 1 whole. But we're not talking about just that one. We're not talking about just that whole. We're talking about and 1/4. 1/4 greater than 1 or that whole. So, much like 1 and a fourth, 1 and a fourth actually could be represented as an improper fraction. It has 1/4 greater than 1. Let's also take a look at decomposing a mixed fraction or a mixed number. This 1 whole, whether it's quarters, eighths, sixteenths, is indeed a whole. We know a whole has 4/4. But because we're talking about a mixed fraction, we don't even talk about it. We don't even reference it when we're showing it as a mixed number. But we're also incorporating or showing, representing that 1/4. So, and is like saying I'm adding that 1/4. 1 whole, a number, plus a 1/4 would equal 1 and a fourth. A number, an integer, which is a whole, not a fraction, and a proper fraction, 1/4, make a mixed fraction. So actually, mixed fractions and improper fractions can be equivalent. Improper fractions can be equivalent with mixed fractions, much like we found here. 1 and 1/4 is equivalent to 5/4. That is because 1, 2, 3, 4/4 is a whole with another fourth added, greater than a whole. They are equivalent. Let's take a look at one more example for a mixed number or a mixed fraction. Taking a look at those thirds. Our mixed fraction is 1 and 2/3. It is 2/3 greater than a whole. Altogether, 1 and 2/3. A whole with a fraction more. Greater than a whole has an integer, a number mixed with it. So, 1 and 2/3 represented with our trusty measure magnets, fraction magnets. Okay? So, we have that whole, and we have that 2/3. 1 and 2/3. But what makes that whole? When we're thinking about fractions, we always need to think about the parts that make that whole. This whole could be partitioned into any number of parts. But when we have 2/3 as our proper fraction that is mixed in to our mixed fraction, we can think of that whole as if it was partitioned into the improper fraction that is mixed in. So, as we know, when we're talking thirds, 1, 2, 3/3 make that whole. But we're talking more than a whole. We're talking about 2/3 greater than a whole. 2/3 greater. 2/3 greater. So, much like having our whole with 2/3, we need to continue adding the thirds that are left over or are greater than that whole, which would be 2/3. I know parts that make that whole cannot change. 3 plus 2 is 5/3. 1, 2. 3/3. 3/3 make our whole plus those 2/3 more. Make that improper fraction 1, 2, 3, 4, 5, 5/3. But our mixed number has 1 and 1, 2, 2/3. But indeed, they are equivalent. Parts that make the whole remain the same, even if we have a number or integer representing that whole. All right, guys, to get a better understanding about the differences between a proper fraction, an improper fraction, and a mixed number, we can continue comparing. We know now that an improper fraction can be equivalent or the same to a mixed fraction. How? How can we compare these things with the understanding that they can also be greater than, less than, or equal to? Well, when we want to compare an improper fraction to a mixed fraction or a mixed fraction to an improper fraction, we can convert. We can change the way they look to easily compare them, especially when a number shows our whole. Guess what? We can best do that. We can convert using decomposing. See how I did that? Maybe not me. Probably just people a lot smarter than Mr. G. We have an improper fraction, and we want to convert it to its equivalent mixed fraction. How we do that when we're decomposing? First, we need to make the whole. If I know I'm working with fifths, I know that 5/5 will make that whole. So I am going to write 5/5. But we're not talking about a whole. Our denominator is greater than our numerator is greater than our denominator. We know it's more than a whole. We know it's an improper fraction. We're not talking about 5/5. We're talking about 7/5. How many more parts do we have? If I have 5 and I need to make 7, I know that is 2 parts greater. 2 parts greater. 5 plus 2 will make 7 parts. But we're talking about fractions, so we need to keep those parts that make the whole the same. Now we've decomposed our 7/5 into 5/5 and 2/5. The next thing we need to do is add the leftover proper fraction, which we just did. 5/5 is our whole plus those 2/5 left over. 7/5 as a mixed fraction, a whole and a proper fraction would be 1 and 2/5. They are indeed equivalent. Let's take a look at this example by taking the mixed fraction and converting it to an improper fraction. So finding the equivalent improper fraction of the mixed fraction in the example we just did. Let's pretend we didn't know what the improper fraction was. There's a slight difference to convert a mixed fraction to an improper fraction. The first thing we need to do is decompose that whole. We always think about wholes first when we're thinking about fractions. The whole was already made for us, is already made for us, just like we made that whole when we were converting an improper fraction to a mixed fraction. So I need to make that whole, okay? If I am working with fifths, I know 5/5 will make a whole. That whole that is represented as an integer or a number in this mixed fraction, 1 and 2/5. Decompose the whole instead of making the whole. The second thing we need to do, add those leftovers. I know that there are 2/5 more or in addition to this whole. Again, parts that make the whole don't change. They need to be the same parts, equivalent parts. I know 5 and 2 parts greater will make 7/5. I decomposed my whole into parts or an improper fraction. I took my leftover fraction, which was an improper fraction. I put them together to get just an improper fraction. 1 and 2/5 is equivalent to 7/5. Converting mixed fractions to improper fractions. So, knowing that improper fractions and mixed numbers can be equivalent is a great understanding for when we begin comparing not only improper fractions to mixed fractions or mixed fractions to improper fractions, but also when we are comparing all of them together later in our lesson. We can do that by using the similar strategies we just did, finding the equivalent of mixed fractions and improper fractions by using decomposing, or in the length model that I can show you in just a sec. So comparing 3/2 to 1 and 1/4. Right away, I need to recognize that 3/2 is an improper fraction. It has a numerator greater than its denominator, so I know it is greater than a whole. And 1 and 1/4 is a mixed fraction because it has a number and an a proper fraction. So to make this all make sense when comparing, they need to look the same to help me, perhaps, in my brain. So I could use decomposing, but I could also do that using the length model. So first thing I need to do is first make that whole. I know when I'm working with halves, there are two parts that make that whole. 1, 2. That would be 2, 2. That would be 1. But we have 3 halves. I need to make another whole, okay, of 2 parts. So here I have 2 2s, okay, and I have another whole. I need to only add one more part. I know that another 2 2 would make another whole, but we're not talking about 2 more halves. We're talking about just 1 more half. So I made my whole, 2 2s, and in addition, I had 1 more half, 1 more part, which is 1 half. So I can convert my improper fraction to a mixed fraction by decomposing, also using the length model to help me. 1 plus 1/2 would be 1 and a half. So 3 halves is also equivalent to 1 and 1/2. Now I have 2 mixed numbers I now can compare. Well, I know 1 whole and 1 whole are the same. But I also know that 1/2 is greater than 1/4. When a whole is split into 2 parts, the parts are greater in value. When our denominators have smaller numbers, the parts are bigger. 1/2 or 3 halves is greater than 1/4. Let's take a look at another example. Now I'm comparing 9/8 to 1 and 1/4. I first need to know, again, that this is an improper fraction and this is a mixed number. This time, let's convert this mixed number to an improper fraction to compare them. So, where do I start first? I need to start first with decomposing that whole. Okay, so if I were to decompose that whole, and I'm talking about fourths, okay, I would need to know that 4/4 make that whole. Second thing I need to do is add that extra improper fraction. I know that there is 1/4 there. I have 1/4 more than that whole. 1 and 1/4. I then, of course, need to put them together to make that improper fraction. I know that my parts that make the whole never change. 4 plus 1, 4 parts plus 1 part. It's going to give me 5 parts. Talking about 4 parts to make the whole. 5/4. So, if 5/4 is equivalent to 1 1/4, I can now compare two improper fractions. Do you think that made it easier? I did that on purpose. So, what we just discovered is comparing mixed numbers is much easier than comparing improper fractions. So, if we find ourselves comparing improper fractions and mixed numbers, let's convert and compare to make that improper fraction a mixed number. Let's take a look at this example again and apply that understanding. I have an improper fraction, 9/8, and a mixed number, 1 1/4. We know it's easier to work and compare with a mixed number. To do that, we again need to decompose, starting with what makes that whole. Always thinking about what makes the whole when we're working with fractions. I know I'm working with 8s. 8 parts makes the whole in 9/8. So that means 8/8 will make our whole. But we don't have 8/8 here. We have 8 parts. We need, or what is represented is 9 parts. I know if I have 8 parts and I need to get to 9, that is 1 more part. But parts of what? Parts that make what whole? 8. 8/8 as a whole plus 1/8 equals 9/8. Our 9/8 as a mixed number would be 1/8, 1 whole plus 1/8, which would be 1 1/8. Which is greater? Which is less? Are they equivalent? Let's compare. Well, I know that 1 whole and 1 whole, again, are equivalent. They are 1 whole. But when I look at my improper fraction in these mixed numbers, I know as my denominators are smaller, the parts are bigger that make that whole. I know that 1 1/4 is greater than 1 1/8. Tough stuff. And that's we do. Let's continue to use models and strategies, such as decomposing, to begin comparing mixed numbers and improper fractions. What we figured out in that I do is a number of things. But one key understanding is that it is much easier to compare a mixed number to a mixed number or fraction rather than an improper fraction to an improper fraction, especially when those parts that make the whole or those denominators are not the same. Remember, with the we do, we are working together. So always have the option to stop that video and catch up. You got your piece of paper, your pencil, the materials that you needed for this lesson out in front of you, actively doing pretty much exactly what I'm doing. We are working together to compare improper fractions and mixed numbers. Here is our expression. 1 1/3 is it. greater than, less than, equal to 5/3. We are comparing them using our symbols of comparison. First thing, we need to understand which is the mixed number, which is the improper fraction. I see a 1/2. I know this is the mixed number. We know this is the mixed number, and this is the improper fraction. We know it's easier to compare a mixed number. We need to make this improper fraction a mixed number. Let's use decomposing. If you don't have what I have, stop the video or get it on your paper. So, first thing we need to do to convert this improper fraction to a mixed number, we need to think about that whole, guys. Always thinking about what makes that whole when we're working with fractions. We know we have a 3 in the denominator. We know improper fractions are greater than a whole. We need to make our whole. What is going to make our whole if we're working with thirds? We know that 3 parts, equal parts make the whole. Therefore, 3 of those parts would make 1 whole. 3/3. We made our whole. Done. The next step is we need to figure out what parts are in addition to or greater than that whole. I know I have 3/3 to make the whole, but I need to have 5/3. I have 3 parts. I need to make 5 parts. So, how do I get from 3 to 5? I know I'm adding 1, 2. 2 more parts. Parts of what? Parts that make what? 3 parts that make that whole. 1 2/3 is equivalent to 5/3, but we converted it to make a mixed number. Look at that. Much easier. Now I'm comparing 1 1/3 to 1 2/3. Let's compare. I know 1 whole and 1 whole are the same. They are 1 whole. But looking at the improper fractions, I have 1/3 and 2/3. Let's take a look at it on the length model. Look at that. Mr. G coming at you with a model. We're both comparing thirds. I know that that whole is made out of thirds. This would be 3/3. This would be 0. 2/3, 1, 2 would be here. 1/3 would be here. 2/3 is clearly 1/3 greater. Alligator eats the bigger value. 1 2/3 is greater than 1 1/3. Therefore, 5/3 is greater than 1 1/3. Comparing by converting into a mixed number to help us. Let's move into that second we do. Comparing 5/4 to 1 1/2. Comparing an improper fraction to a mixed number. I know it's a lot easier now to compare a mixed number to a mixed number. So we need to convert these 5/4. We do that by decomposing first. You just start with that whole. What makes the whole in 5/4? There are 4 parts that make that whole. 4 parts of. What is the parts of 4? 4 parts of 4 that make the whole would make indeed our whole. Second step, what is in addition to that whole? We know improper fractions and mixed fractions are greater than one whole. How many more parts are in addition to this 4/4? Well, I know I have 5 parts. Parts that make the whole don't change. How many more parts are in 5/4? Well, if I have 4 and I need to get to 5, how many more guys is that? That is 1 more part. Just 1/4 more. So 5/4, I decomposed my whole. I found out how many parts are left. 5/4 is 1, and 1/4 as a mixed number. Now we can compare our mixed number to our mixed number. Okay? Much easier. I know that 1 whole and 1 whole are the same. So now I must look at what our proper fractions values are. I can compare 1/4 and 1/2. Let's use 2 length models to compare. Make length models with me right now. Pause the video if you need to. I have 2 wholes. We are comparing 1/4 and 1/2. If I were to make this whole into fourths, I would need to partition 4 equal parts. What about 1/2? I know 2 parts make that whole. Make your length models look like this. Stop the video if you need to. Now let's compare. I'm comparing 1/4 to 1/2. I know there's 1 part or 1/4 represented here, and I know that 1/2 is represented here. Let's compare. 1/4 is definitely less than 1/2. 1/2 is definitely greater than 1/4. Oh, excuse me, I'm running away. 1/2 is greater than 1/4. 1/4 is less than 1/2. We know that 5/4 is less than 1 and 1/2 when comparing using models and converting those improper fractions into mixed fractions. All right, guys, last we do, let's hang in there. Let's yearn to learn a little bit. Comparing 5/3 to 1 2/6. I first need to know again that this is an improper fraction, this is a mixed fraction. It is much easier to compare a mixed fraction to a mixed fraction. We need to convert this improper fraction into a mixed fraction or mixed number. Have to start with parts that make that whole. I am working with thirds. How many parts of thirds, 3 parts making that whole, would make 1 whole? Our whole fraction would be 3/3. 3/3. That is our whole. How many more parts are there in 5/3? How many parts more than a whole are in 5/3? I know I'm still working with thirds. How do I get from 3 parts to 5 parts? I know it's 1, 2. 3 plus 2 is 5. 2 more parts would make 5/3. 1 with 2/3 more, and 1 and 2/3. 1 and 2/3 compared to 1 and 2/6. Yikes. Kind of a challenging comparison. Let's use a length model. I know that 1 and 1 are the same, but the question is, which is greater or less than or equal to 2/3 or 2/6? Let's make a comparison using our length models. We are comparing 2/3 and 2/6. Our numerators are the same, our denominators are indeed different. With me, let's partition thirds. I know 3 equal parts make that whole. Stop the video if you need to. Make these length models look like mine. I know 2/6. 6 parts make that whole. I'm Mr. G, and from my last lesson, I know 6 is an even number. It has exactly half. 3 making both those halves. 6 equal parts. Let's compare. 2/3, 1, 2. 2/3 represented on the length model. 2/6, 1, 2. 2/6. Which is greater? 2/3 or 2/6? Well, on my length model, 2/3 is clearly greater than 2/6. 5/3 is greater than 1 and 2/6. Great job. All right, guys, moving into the last step of our learning model for today's lesson, that you do. So, we now learned or relearned about the 3 main forms a fraction can be represented. We learned now that improper fractions and mixed fractions are representations of fractions greater than a whole. We are still comparing fractions to have a better understanding of what fractions are and their value. Your you-do will be working primarily on understanding improper fractions and mixed fractions by comparing and thus converting them, along with continuing to compare those other, now we know, proper fractions. We will be revisiting, or actually moving forward with our next learning target in our next lesson. I will be breaking these skills separately into 2 parts. A lot of great learning in this lesson. We need to pump the brakes a little bit. Save our other learning target for next lesson.